Prism. What is a prism? A prism is a solid, homogeneous. What is the meaning of homogeneous? Made of same material. Transparent. Meaning of transparent is light can pass through. And refracting medium bounded by two plane refracting surfaces inclined at an angle. So this is the definition of prism. A prism is a solid, homogeneous, transparent refracting medium. Okay, I am going to draw the prism, just see. See, this is a prism. Say, let this be A, B, C, and this be D, E, F. So it is a solid, homogeneous, transparent refracting medium bounded by two refracting surface. So, see, there is a surface here 1 and there is a surface here 2. These two are 1 and 2 are refracting surfaces. These two surfaces are inclined at an angle. See, this is called A. A is angle of the prism. And see, AD is the edge. AD is the edge of the prism. And this is the base. BCFE is the base of the prism. So this is a prism. Okay. Refraction through a prism. Just I am going to draw the diagram. Carefully notice, it is very easy. So see, there is a prism. Okay, there is a prism, say A, B, C, and this is called the angle of the prism. Now, an incident ray is incident on the first refracting surface AB. So, I have to draw the normal. Normal will be perpendicular to AB. So, the light will bend towards the base, and again from denser to rarer it goes like this, right? So again in the refracting surface AC I am drawing a normal. Okay, so this is the path of light. So this is the ray that is refracted through a prism. Now the angle, the incident ray, so this is the incident ray, makes with the normal is the angle of incidence. Again in this phase, this is the normal. The angle the refracted ray makes with the normal is called angle of emergence. Just see this ray, okay, this ray, say, okay, PQ. Let this ray be PQ. Okay. So this ray, if this refracting surface is not present, this would have gone like this, right? But the direction is in this way. Just produce it backwards. So what will happen? So this is delta. See, this is the angle of deviation. This is the angle of deviation. Just I am noting down everything. A, angle of prism. A is the angle of the prism. I, angle of incidence. E, angle of emergence. And del, angle of deviation. Okay. Now, this is refraction through a prism. This is refraction through a prism. Now, see, for any prism, angle A plus angle D will be equal to angle I plus angle E. This equation is true. Okay. So, let us see how we can prove this relation. Angle A, delta, I and E. In some books, instead of delta, D is given. D is the angle of deviation. To prove this relation, I am just marking the ray diagram. So let this point be Q. PQ is the incident ray. Okay, this point be Q and this point be R. And this be E and this point be D. Okay, and this is the angle of refraction at the first surface. Angle of refraction at the surface AB. So R is angle of refraction at AB. And here let this be R dash. R dash is angle of incidence at AC. Second surface angle of incidence is R dash. Okay. Now we are going to prove angle A plus angle D is equal to angle I plus angle E. Okay. Now see, let us take in quadrilateral AQER. AQER. See, AQER. In a quadrilateral, the sum of all the angles will be equal to 360 degree. Am I right? So, I can write angle A plus, see, this angle will be 90 degree. This angle will be 90 degree. So, AQE 90 degree. And here, ARE, this is a normal. So, this is 90 degree. Plus E is equal to 360. Am I right? So, can I write A plus E is equal to 180 degree? So, I got this. A plus E is equal to 180 degree. Again, see in this triangle, in triangle QER, triangle QER, we have R plus R dash plus E is equal to 180 degree. So, we got these two relations. So from this and this, see, R plus R dash is equal to A. So this implies R plus R dash is equal to A. Okay. Now, in triangle QDR, exterior angle delta is equal to, see, this angle and this angle, sum of these two angles. This is I minus R plus, this is E minus R dash. So I can write delta is equal to I plus E minus R plus R dash. But R plus R dash is A. So delta is equal to I plus E minus A. That is, A plus delta is equal to I plus E. So we got the relation angle A plus angle deviation is equal to angle of incidence plus angle of emergence. So for any prism, this relation, this equation is true. Okay. Now we are going to find out the position of minimum deviation of the given prism. So what are the factors on which deviation produced by a prism depends? So deviation produced by a prism depends on, first one, angle of incidence, then refracting angle, that is angle of the prism, refracting angle of prism, and finally the material of the prism. So see, one prism at any one angle of incidence, it will have the position of minimum deviation. So I am going to draw an ID curve. Okay, we call it graph also. Okay, ID curve. See, just I am drawing a graph along x-axis, angle of incidence I and angle of deviation here. Okay, so just see, let this be 30, 40, 50, let this be the y-axis and this is the x-axis. Okay, so here 10, 20, 30, 40, 50 and so on. So when angle of incidence increases, the deviation will decrease. Okay, so it keeps on decreasing, at a particular angle of incidence, the deviation starts increasing. Okay, this is the deviation starts increasing. So for one and only one particular angle of incidence, one particular angle of incidence, we will get the minimum deviation. That is, the prism produces minimum deviation. The prism produces minimum deviation for one and only one particular angle of incidence. So that is called, so this curve is called ID curve or I delta curve. So this is called position of minimum deviation of the prism. You have to see few important things when you are studying about the position of minimum deviation. First one, at position of minimum deviation, angle of incidence will be equal to angle of emergence, and the base angles, I have drawn that R and R dash are equal, and the refracted ray through the prism will be parallel to the base. The light that is passing through the prism passes through the prism parallel to the base. See, these three things you should know. One more time, at the position of minimum deviation, angle of incidence will be equal to angle of emergence, R will be equal to R dash, and the light, just I am going to draw and show. More time, see, this is the prism. Okay, this is angle of the prism. So see, this is the incident ray. Okay, let this be PQ, and at position of minimum deviation, so I have to draw the normal. See, this is R, this is R dash, this is angle of incidence, this is angle of emergence, and the ray would have gone like this, but it has come here, and this is position of minimum deviation. So P, Q, R, am I right? Yes. And this is A, B and C. So here angle of incidence will be equal to angle of emergence. This is the first thing at position of minimum deviation. Second one, we have R will be equal to R dash. Base angles are equal. That means this ray QR will be parallel to the base. That is QR parallel to BC. That is base of the prism. The light passes through the prism in a parallel way. So these are the three things that we should know while studying the position of minimum deviation. The position of minimum deviation is occurring at one and one particular angle of incidence. When the angle of incidence increases, the angle of deviation decreases. For one and one particular angle of incidence, the deviation will be least. After that, it starts increasing. That is called position of minimum deviation of the prism. For any prism, refractive index mu, sometimes they write n, refractive index n is equal to sin A plus delta m, that is minimum deviation, position of minimum deviation, by 2 will by sin A by 2. We have to prove this formula where the symbols have their usual meaning. Okay, so at position of minimum deviation, the refractive index mu is equal to sin A plus d by 2. D is d minimum deviation by sin A by 2. So you all know the diagram. At position of minimum deviation, at position of minimum deviation, what do we have? We have one, angle of incidence will be equal to angle of emergence. and R will be equal to, the base angles are equal, and this QR will be parallel to BC. These three things we have already found that also R plus R dash is equal to A. So, but R is equal to R dash. So, can I write 2R is equal to A, or R is equal to A by 2? Okay. The next one, again, A plus del M I am writing, minimum position, is equal to I plus E, and I is equal to E, therefore A plus del M will be equal to I plus I, that is A plus delta M is equal to 2 into I. So A plus delta M by 2 is equal to I. So now applying Snell's law at Q, applying Snell's law at the point Q, the refractive index of the material of the prism, the refractive index can be written as N will be equal to sin I by sin R. So applying Snell's law at point Q, the refractive index of the prism, mu is equal to, we know, sin I by sin R. But what is sin I? That is mu is equal to sin A plus del M by 2 divided by sin A by 2, where A is the angle of the prism, del M is the position of minimum deviation of the prism, and mu is the refractive index. So, knowing A, that is angle of prism, del M, angle of minimum deviation of the prism, we can calculate, mu can be calculated. We can calculate refractive index.